Let us take a question paper problem of VTU. So VTU January 2016. Of course, in this problem, the question is like this: resolve 300 Newton force acting on a block as shown in figure number 1 into horizontal and vertical components, first part. Second part, along the inclined plane and right angle to the plane. Along the inclined plane and right angle to the plane. Yeah, this is not a resultant problem. Here he has given a force acting on a block resting on an inclined plane, and just he has asked you to resolve that force into two components. So the diagram is given like this. You have a 20-degree inclined plane like this. On this inclined plane you have a block resting, and he has given a force which is acting at 300 Newton force acting at an angle of 30 degrees. So like this, see, 300 Newton force is acting like this. It's a push force. This angle is 30 degrees. So this is what he has given. He has asked you to find the components of this 300 Newton force, of course, along two sets of coordinate axes. So here the first set is along the global horizontal and vertical component. That means you have to resolve into these two directions. And the second set is we have to resolve the same force along two axes of reference. One axis is along the inclined plane, so that means your x-axis will be inclined plane like this, y-axis will be perpendicular. Please note, I can call it as x dash y-dash. So xy is x-axis and y-axis, they are the global horizontal and vertical axis of reference. X dash y dash, they are the local axis of reference. So parallel to the plane is x dash axis, perpendicular to the plane is y dash axis. You please note that here the angle is different here. So if you draw a horizontal here, please observe here, it's very important. If you draw a horizontal here, so what will be this angle? So this angle will be equal to 20 degrees. This is because these two are alternate angles. They look like this. See, and this is theta. This will be theta. So these angles are called as alternate angles. So this angle now becomes 20 degree. When this angle becomes 20 degree, naturally this angle becomes 10 degrees because the total is 30. Total angle of this force with respect to plane is 30 degree as given. Among that, this is 20. You draw a horizontal, so this will be 20. When this is 20, this becomes 10 degree. So that means if you take your x-axis, so this is the x-axis now. This becomes the x-axis now. If you take the x-axis, that 300 Newton force is making an angle of how much? 10 degrees with x-axis. That is very important. So this is making an angle of 10 degrees. So it will be like this. This angle is 10 degrees. That's what. So this is 10 degrees. Now you can easily resolve this because along the global x and y axis means this is your global x and y axis. If you resolve that 300 Newton force, horizontal component will be like this, vertical component will be like this. Since this 10 degrees made with respect to horizontal, this horizontal component will be 300 cos 10 degree, which is acting towards right. So start from the tail, move towards the tip. This is the horizontal component, and vertical component will be downwards. Sin 300 sin 10 degrees. So if you simplify this, you will get 300 cos 10 degree is how much? I will tell you, 295.44 Newton. 295.44 Newton, which is acting towards right, and 300 sin 10 degree, 300 into sin 10 degree will be 52.09 Newton. So these two are the components along with the directions when you resolve this 200 Newton force into horizontal and vertical components. Now the second part, he has asked the resolution along the parallel to the plane and perpendicular to the plane. If you take parallel to the plane and perpendicular to the plane, this 300 Newton force, you can see here, this 300 Newton force is acting at an angle of 30 degrees only with the plane. Okay, now this is the plane. The angle made by this 300 Newton with the plane is given as 30 degrees. So now the axis of reference will be now, this is x dash axis parallel to the plane, perpendicular to that is y dash axis perpendicular to the plane. Now if you resolve this 300 Newton along these two, so please note that this is the tail, this is the tip. Now you have to start from the tail, move towards the tip along the plane. So this is the component. Start from the tail, move towards the tip perpendicular to the plane to this way. So please note that when you are resolving, these arrows should meet at the common point. This arrow and the force arrow, they should meet at the common point. Please note that this is 30 degrees with respect to x dash axis. Therefore, since this becomes the adjacent angle, therefore this is 300 cos 30 degree and this becomes 300 sin 30 degrees. So this is the component. Okay, so now 300 sin 30 is 150 Newton. 300 cos 30 will be 300 into cos 30 will be 259.8 259.8. So perpendicular to the plane, the component is downwards, which is 150 Newton. Parallel to the plane is upwards, 259.8 newtons. So this is how they can ask you to resolve the force itself along the two mutually perpendicular directions. They may give either global coordinate axis, horizontal or vertical, or they may give local coordinate axis along the plane and perpendicular to the plane, parallel to the plane and perpendicular to the plane. So this is also important because whenever we solve problems on inclined planes, maybe friction problem like that, we have to resolve the forces along the plane, parallel to the plane and perpendicular to the plane. In those types of problems, this concept of resolution is very, very important. Now, one more problem, same paper, question paper. So he has given one more problem. You can just take, the question is like this: determine the resultant of the forces. Determine the resultant of the forces. So he has given this for 10 marks. 10 marks. Now he has given the figure. So this is the figure which is given. X-axis is like this. Y-axis is like this. It is coplanar or concurrent force system. Origin is this. He has given first force in the first quadrant like this, 200 Newton. Instead of giving angle, he has given slope. So one vertical to two horizontal. So from that we can get the angle. Suppose if this angle we can take it as theta, we can always find out that angle theta 1. Theta 1. So tan theta 1 we can find out. Then he has given a force 50 Newton, making an angle 40 degree is vertical. Please note that 40 degree is vertical. Then in the third quadrant he has given another force 50 Newton, making an angle 60 degree with the horizontal. Then he has given one more force 120 Newton in the second quadrant, which makes which has got a slope of 4:3. 4 vertical to 3 horizontal. So like this also they may give. Instead of giving angles, directions instead of giving in terms of angles, they may give in terms of slopes also. So in that case, only thing is we need to find these angles. So this becomes, let me take that as theta 2. Theta 1, theta 2 we have to find out now. So the question is we have to find out the resultant as well as the magnitude of the resultant R and direction of the resultant alpha. Position is not required because it passes through the point of concurrence move. Now let us find out theta 1. So what is tan theta 1? 1 by 2. So you can find out theta 1 as tan inverse of half. Tan inverse of half which is tan inverse of 0.5, 26.56 degrees or 26.6 degrees. Then tan theta 2 vertical by horizontal 4 by 3. So tan inverse of 4 by 3 is theta 2. So that is tan inverse of 4 divided by 3, which is 53.13 degree. So these angles must be find out. Then next step is to resolve into horizontal and vertical components. You know how to resolve. So the first in the first quadrant, this 200 Newton force is there. Start from the time, move towards the tip. Horizontal component is this, vertical component is this. Since here this theta 1 is with respect to x-axis, cos will be this component, sin will be this component. 200 cos theta 1. Theta 1 is 26.6 degrees, and this is 200 sin 26.6 degrees. So find out the angle from the slope. Here, in terms of angle only he has given. Of course, the angle is given with respect to vertical. When they give the angle with respect to vertical, so this component becomes cos. This component, because this is the adjacent angle, this becomes sine. So that means 50 sine 40. This is 50 cos 40. Otherwise, you have to convert this 42 in with respect to x-axis. It becomes 90 minus 40, 50. So this will be 50 cos 50. This will be 50 sin 50, which is the same. Cos 40 is the same as sin 50, and sin 40 is the same as cos 50. So that you know. Next, here he has given the angle with respect to horizontal. Therefore, if you resolve this, start from the time, move towards the tip. So sigma, that x component will be negative. Y component is also negative because it is third quadrant. 50 cos 60 we have to take. 50 cos 60, this becomes 50 sin 60. Then the fourth force in the second quadrant, start from the time, move towards the tip. Since the angle theta 2 is with respect to x-axis, so if you resolve, this will be negative, this will be positive. So this will be 120 cos theta 2. Cos theta 2 is 53.13 degree, and this becomes 120 sin 53.13 degree. So this is how when they don't give the angle, if they give the slope, you have to take the tan ratio and get the angles. Now after resolution, we have to find out sigma effects, taking forces acting towards right positive and left negative. So here, one by one, there are four forces. First, I will take this 200 cos 26.6 towards right, it is acting, so it is positive. 200 cos 26.6 degree. Then second force is also positive, plus 50 sin 40. Then third force becomes negative because it is acting towards left, minus 50 cos 60. Then fourth force is also negative, minus 120 cos 53.13 degrees. Now we have to simplify this. So be careful in writing the positive and negative signs. So 200 into cos 26.6 degree plus 50 into sin 40 minus 50 into cos 60 minus 120 into cos 53.3. 0.13. Yeah. So it becomes 113.97. You can take okay 113.97 Newton. So positive we have got. Therefore, it is acting towards right. That is simple. So positive value, if you get sigma x positive, it will be acting towards right according to same convention. If you get negative, it will be towards left. Similarly, sigma fy, I will take upward forces positive, downward negative. One by one we will take. So this is acting upwards. 200 sine 26.6 degree. 200 sine 26.6 degree. This is acting downwards. Minus 50 cos 40. Then coming to this, it is acting downwards. Minus 50 sine 60. This is acting upwards. Plus 120 sine 53.13 degrees. So once again we will simplify this. 200 into sine 26.6 minus 50 into cos 40 minus 50 into sine 60 plus 120 into sine 53.13. So you will be getting a value 103.95. 103.95 Newton. It is also positive, that means upwards. Now once you get sigma fx and sigma fy and their directions, you can fix the direction of the resultant now, in which quadrant it lies. You can find out its magnitude as well as the direction alpha. Now we will see in what quadrant that sigma that r lies, because both are positive here. Sigma fx is positive, sigma fy is positive, r lies in the first quadrant. So sigma fx towards right, sigma fy upwards, therefore r will be like this. So alpha is this side. Now the magnitude of r is given by sigma fx square plus sigma fy square under root, which you will get 113.97 square plus 103.95 square. So if you simplify that, 113.97 square plus 103.95 square under root 154.26 Newton. This is the magnitude of resultant, and the direction alpha is given by alpha is equal to tan inverse of modulus sigma fy by sigma fx, which is tan inverse of 103.95 divided by 113.97. So you will be getting 103.95 divided by 113.97, tan inverse of that. So you will be getting 42.37 degrees. So that alpha angle, this gives the direction of r. So here in this alpha value we got 42.37 degree, magnitude of r 154.26 Newton. So this is how. So this problem why I took is in this case he has, instead of giving angles of the forces, he has given slopes. So from the slopes, by taking tan ratio, you can find out the respective angles. Later on, we have to resolve, find out the algebraic sum sigma fx, sigma fy, and in each quadrant that r lies depends on the directions of sigma fx and sigma fy. Then you can find out the magnitude and direction and plot the resultant in the sketch. So if you just to show like this, so this itself becomes this x-axis, y-axis, origin. So it passes through the origin. This becomes the resultant.